right? So yesterday we talked about, right, we started page 40, we wrote a bunch of inequalities. I think what I wanted to tell you yet is, just to help you out, I kind of categorized them on my own little notes, if I find it. If I don't find it right away, I'll give you that later. I need to just move on with this. Yeah, I'll give you that later. I kind of will tell you, hey, if you see these keywords that's less than or equal to, if you see these keywords as greater than or equal to. So I'll kind of categorize them like that a little later. So let's go to page 41 here. And these are the steps that they're basically going to stay the same, guys. I'm going to step up. We're going to do word problems, word problems, word problems. And every time we're going to step it up a notch. At the end of this unit, the word problem will follow the same steps. We're going to graph it. We're going to find the POIs. And notice that it says here, state a possible solution. Notice that, a possible. At the end, we're going to figure out the best solution. That's where we're going to end up with. So the first couple of steps are not going to change. That is going to stay the same. It's the end here where I'm going to add a little bit. Okay. So we're going to introduce our variables. What is X? What is Y? State the implicit constraint. It's always going to be that. We're always going to assume that X and Y need to be positive. Write the inequalities presented by the question. Each restriction, that's what I'm going to highlight here. Each restriction should be represented by an inequality, right? So if you see at least or greater than or anything like that, you need to have an inequality that goes with it. Don't just let it be, right? You're like, I kind of figured it out already with this inequality here. No, every keyword needs to have an inequality with it. Graph, right? Then we graph them, state the POIs, round if discrete. Okay, that's important there. State a possible solution found in the solution region, also known as the feasible region. And you're gonna maybe sigh at this, but also known as the solution polygon. All mean the same thing. Solution region, feasible region, solution polygon, and sometimes the true region, right? It's all the same thing. So don't let that throw you off. Okay, so that's kind of, if you want to have that on your study sheet, you may. Quite often my questions kind of guide you through that anyways, but that's how you would tackle it if no instructions are given to you. Okay, so here it is. Word problem with one inequality. A certain manufacturer makes scarves and toques. It takes 50 minutes to produce a scarf, 10 minutes to produce a toque. The company has up to 2 hours of production time available. Graph the solution set, state the points of intersections, and then give a possible solution. Okay, you should have, when you read this whole thing, 15 minutes to produce a scarf, 10 minutes to produce a toque. There's no restriction there. It's just telling you what it is, right? That it takes this long to make that, this long to make a toque. But when you keep reading, the company has up to 2 hours of production time available. That right there should tell you there's an inequality, right? There's some kind of restriction placed on the time available. And that right there should indicate there's an inequality present. Okay? It doesn't say has exactly 2 hours, right? It says up to. It could have said has a minimum of 2 hours or something like that, right? It could have worded it differently, but it says up to 2 hours. Okay? So we'll do this. Let X represent the number of scarves, right? And Y will be the number of toques. I will just make a note right away. What kind of data is this, discrete or continuous? And sometimes Reggie, were you gonna discrete? Yes. You're not measuring anything, right? It's not like how long something is or how much money or anything like that. This is discrete. You can technically, you can only have whole quantities. So I make a note for myself right away. Okay, oh, that means that I will round POIs. Therefore, round POIs. That's what that means. So I'm telling myself that before I get there even, because you forget, right? The implicit constraint would be X and Y would be, obviously you can't have negative scarves or negative tubes unless you are my boys, right? My two boys, they lose gloves and toques. They lose their stuff all the time. So I think I'm in the minus on that one. But anyways, different story. So now is my inequality. This is the important part. The most important part is to make account for that. And I will use this, right? It takes 15 minutes to produce a scarf. And it would take 10 minutes to produce a toque. Right? And so this would technically give you the time spent on production, right? And you know that this needs to be less than or equal to, what are we going to put down here? This is in minutes, right? And 2 hours, we just have to convert 2 hours to minutes, right? So we'll just do 2 hours, right, times 1 hour has 60 minutes, right? The hours cancel out, that's 120 minutes. I need to have that in minutes, so you either convert the minutes you were given into hours, or you convert your hours to minutes. But I always choose to go to the smaller unit if I have a choice. So there it is. That's my one inequality. That's the only thing that it's saying. It could have said, I'm going to give you a heads up. It could have said, the company needs to make at least 50 toques and scarves combined. They could have said that, right? So then you would have had another inequality here, right? So that's what we're going to do as we go on. But anyways, let's just work with this one. So once you have your inequality, it goes back to what you did at the very beginning. You find your intercepts. Let's go ahead and do that. 15x is equal to 120. So we just for a minute worry about the boundary line. Okay. And that is 880. The intercepts, ladies, like it may be a POI down the road, but for now we're just going to use it to graph. Okay, that's what we're going to use it for. 10y is 120. Divide both by 10. Y is equal to 10. So that's 0, 10. And there you have your, this is for graphing purposes, and you rewrite just like before. So I've trained you on this quite a bit, right? You've done a lot of this. And can I tell you one more thing? You're gonna have very few negatives when it comes to word problems. Yeah.
Is 120 divided by 10 12 or 10?
It's 12. Yeah. And see, this is the frustrating part for you and for me. So let's say you don't catch this and you graph the whole thing, right? That's on me, right? And I have to check. You have to go and do exactly what you've done, and it's a silly mistake. I'm not too worried about that, to be honest. But don't do it. Don't do it. Okay? I don't want to go through the nightmare of marking that. We're good, right? Everything else is good. Thank you. Thank you for not letting me finish the whole question and then telling me, Mr. Dixon, isn't that wrong? I appreciate that. And you will notice that Some of your IPR teachers would probably be very upset at me for not reducing fractions, right? And the reason is that we are past that. We're trying to graph, we're using our graphing calculator, and sometimes when students reduce, it makes everything be wrong, and I don't want that. Or students will get it into a decimal and then just use 2 decimals. I want all decimals, right? So that I kind of just keep it like that. Okay, so now we know it's a solid line. It will be 99.9% of the time. For word problems, it will be a solid line. The true region is below. We will shade above. What should we do, reverse or regular shading? I don't really care. As long as you tell me where the true region is. But I will tend to go with reverse because it makes it easier, because soon we will do systems, guys. We're not going to stick with one inequality. You know that already. If you don't know, now you know, right? So you graph it. So you stick to the first quadrant. Where's the grid? Where's the grid, Mr. Agent? I find that grids are, when it comes to word problems, not as beneficial, because when you do it yourself, you can just come up with a scale that you'd like. Okay. So before we start graphing, label. Okay. X is what? Number of scarves. You don't need units because it's number of, right? It's scarves, number of, right? And then the top is number of toques. So that's done. And now I need my scale. You notice that the x and the y-intercept, they're soon going to be in the hundreds and the thousands, but that shouldn't scare you. You just pick an appropriate scale. So if I go out 10 here, or 12, whatever, and I go up to, 15 or 14, something like that, that'll work out for me. So I'll just give it a try. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pretty good, right? That'll work because 80 is right here. You don't need to label it. You just need to put it in the right place because you've already done the work on the side here. I don't want you to do double the work. Okay. And then 0, 12, I might have to pick a different scale or go up by a smaller increment, right? So I'm going to make it closer together. 1, 2, 3, 4, 5. 1, 2, 4, 5. That's 10, 11, 12. So I was a bit too ambitious there. If I can, I like to spread it out. Right, if I can. So notice that to the best of my ability, I try to space it out equally. You notice that the spacing is different than the x-axis, correct? That's okay, right? As long as you're consistent within the axes. So then 0, 12 is up here, as opposed to 0, 10, right? And then it's a solid line. I label it right away. 15x plus 10y is less than or equal to 120. And I'm supposed to shade above, according to this. And it's just 1. It's so far, this is probably for you, this should be very easy to graph, just one inequality, but it's coming up with all the components, right? So just a light shading, right? Nothing too crazy. And so this is our solution region. Why? Because I'm focusing on this, right? Where is the true region? It's below the line, and that's what we're really interested in. Possible solution, or POIs. You need to figure out the POIs. And you do not need your calculator for this one. You can actually read them all. And I need you to make sure you understand this. When it's a word problem, the x and the y and the x-axis act as lines, as boundary lines. Okay? it's as if you're shading everything here and here, right? So these are actually POIs. There's 3 corner points surrounding your solution region. If this had not been a word problem, there would actually be no POI because it's not intersecting with any other line, right? But now that it's a word problem, we have our solution region. So actually 0, 0 would be one of them. And we know 0, 12 up there. And we know that this is 8, 0 out here. None of them gave us a decimal. No need to round your POIs. If they had been, which will be the case, then you need to round, right? So we're good to go there. So in fact, you can pick any one of these as your possible solution, right? A possible solution, right? A possible solution would be, let's pick something like 2, 3, right? 2, 3. Producing 2 scarves and 3 toques. Will work. Okay. You could plug that in your inequality and actually make sure, but in this case, I'll just keep it at that. Okay. All right, I'm gonna pause here for a bit, and my strategy now is gonna not be so much, can you do this? Because I know you can. Graphing, especially if it's 1, you're laughing, right? I want you to focus on writing, coming up with the inequality by after reading the problem, okay? So come with me. I'll give you a little bit of class time to do that. So if you go to page 42, 43, you can read the instructions up here, but it's basically asking you to do the same thing as what we've been doing. And so I'm going to ask you to do this. Just write the inequalities, okay? Just write inequalities. But I do want you to let x be something. What is x? What is y? Go through the motions of doing this as well. Right? What is x? What is y? And then write your inequality somewhere here. If you want to graph them later, at home or whatever, I will post a key where I do graph the whole thing. Like every single one is solved and graphed. Okay? But I need you to write the inequalities. That's right now the most important thing for me. So read through these questions. Let your variables be something. Write down your implicit constraint and then your inequality. All right? So let's take some time to do that, and then we'll come back and check how you did. So make sure you follow along. Question 1, motorcycles and bicycles. So that's a pretty good indication that X would be the number of motorcycles. And Y will be the number of bicycles. Okay. And it says they make no more than 400 vehicles in a week. Okay. So both of them combined, right? It's talking both vehicle, not specific to one or the other. And that would be no more than 400. So it had to be like this, right? Oh, it's frozen. There we go. Thank you. So yeah, motorcycles, bicycles. This is the inequality that would make this statement, right, that restriction put on you. And this is the implicit constraint. Next, math and science exams, right? However, what would this be? What would X and Y be? Some of you would just put math and science, right? But it's actually hours. Hours studying for math and this would be hours studying for science, right? So you got to be specific here. Sometimes it's number of just full quantities, and this is hours. This is actually, let's go back here, discrete, and this should be continuous, right? We're talking hours, right? So you can have decimals, it's all good, right? And up to 10 hours studying for the math and science exams. So if you combine the hours spent on either subject, that it has to be less than or equal to 10. There we go. A dealer can purchase touring cycles for $300 and racing cycles for $400 each. She plans to spend no more than $8,400 on that, right? So X and Y would be number of racing, touring. We tend to keep them in order. So just touring cycles, and Y would be number of racing cycles, right? XY is greater than or equal to 0. I forgot to do that up here. Don't forget that. It's very easy to do. But you know what? Also pay attention to what you're doing. I see some students do this. X and Y is less than or equal to 0. It's like, well, now it's negatives, right? So you got to watch out what you're doing there. Right? It has to be greater than or equal to 0. That's what you're saying. It's positive, including 0, right? So here, you actually have a coefficient in front of X and Y. If it's $300 for every touring cycle and $400 for every racing cycle, right? This is going to give you the cost. If you remove the 300 and the 400, it's actually saying the number of cycles, right, has to be less than whatever. But now you're talking cost, and that has to be less than or equal to $8,400, right? Right? These are all dollar amounts, right? If you think about it. So that kind of gives it away there. So this is what I mean, like practice writing the inequality, not graphing right now. We've done a lot of that, right? So now we're going to focus a little bit more on writing, okay? Until tomorrow. Then we're going to start graphing 2, 3 inequalities at the same time. And it is different when it's a word problem, right? Question 4, backside on 43. One cake requires 150 grams of flour, and while a different cake is 75 grams of flour. At most, 2.25 kilograms of flour is available. So here you got to watch out the units. Can you, if you don't mind, okay, you got to watch out for that, right? Like minutes, hours, right? Oh, I need to do something about that. Grams, kilograms. Do you remember how many grams in a kilogram? 1,000. A kilo stands for 1,000, right? Remember that. Kilometer, right? Kilo, 1,000 meters in a kilometer, right? They teach you that, don't they? It's okay. We forget, right? We don't use it all the time. So we just multiply that by 1,000. 1,000, right? So you get that amount. That's what you want there, or else it would be a completely different graph. Okay. Some of you are still like, Mr. Dirksen, it's early in the morning, and I'm still thinking of sleeping. So you got to give me more than that, right? So this is what I'm doing there. You're multiplying this by 1,000, right? Okay, let's go here. What would the units be? What are we talking about here? It's actually the grams, right? Or no, sorry, never mind. Number of cakes, yes, number of cakes. So this would be number of cake A, let's call it A, right? Number of cake type B. Okay. And notice that the question doesn't say the company must produce a minimum of 200 cakes a day. It actually talks specifically, like it puts a restriction. This is at a restriction. At most is a key word on the amount of flour. So it's sorry, not grams, right? My bad. 150x plus 75 grams for a cake B, that has to be at most 2,250, like that. Okay, so I'm going to make an indication that I use, right, grams there. So arrow, 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 right, grams for all of them. Okay, if you have grams here and grams there, this also should be in grams, right? If it's just saying, if you have something about number of cakes, then you should not be using the grams in front of the X and the Y. If it's talking about the number of cakes specifically, okay? Bakery can make no more than a total of 600 muffins and bagels in the morning. Okay, X, Y. What do you want? Muffins, right? Number of muffins, number of bagels. X, Y is greater than or equal to 0. And so in this case, it's just talking about no more. It seems to be less than or equal to, and you're going to think it's always going to be the case. Not always. Maybe I need to change the wording on these. Okay? But this is saying, right, there's technically a 1, right? 1x, 1y, 600. But this is talking about the number of bagels, right? Or number of bagels and muffins combined. Okay. One type of shelf requires 2 brackets, another 3 brackets. There are a total of 42 brackets available to put on several shelves. And so you should recognize this. X and Y, that you should be able to do. Number of shelf A, number of shelf B. All right, and then X, Y is greater than or equal to 0. And you're saying, I don't know if you're thinking it. Are you thinking, hey, Mr. Harrison, it's always talking about brackets though. Like everything is about brackets. You notice that? But if you really think about it, it's the 2 brackets for shelf A and 3 brackets needed for shelf type B, right? And you only have a total of 42 available, right? The brackets are actually the coefficients here. Okay, brackets. So yes, it talks about brackets, but really it's the number of shelves produced that will tell you how many brackets are needed, right? The owner of a sports store orders downhill skis for $200 each and cross-country skis for $150 each. The order cannot exceed, can we change that? It's always the same. Let me think here. How can I reword this to make it a little different? Okay, I will add this. Okay, if you did this already, it's not going to change much. The store can only accommodate up to 500 skis combined. I'm going to add a second one here already to give you. So here, the order, right? The order cannot exceed 6,200, and you can accommodate up to 500 skis combined, right? There's IQ 1, inequality 1, and this is IQ 2 right there. So X and Y, what are the variables here? It's not the dollars, right? It's the skis. Just like before, it wasn't the brackets, it was the number of shelves. So this would be number of downhill skis, and this is number of cross-country skis. Okay. Both of them need to be greater than 0, obviously. And also make a note that this is discrete, right? We had discrete data here throughout the thing. So we can say that, hey, if it's $200 for downhill skis and $150 for a pair of cross-country skis, the order cannot exceed $6,200. This is inequality 1. I just took care of that restriction that was put on there. So there's a restriction on money spent, and then it says the store can only accommodate 500 skis combined. There's only so much space, right? So here you would actually just talk about the skis, right? The number of them combined has to be less than or equal to 500. This is inequality number 2. And I just added that so you could see the difference, right? What does one look like that talks about money? Dollars, 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 right? What does one talk about if it's just a number of items produced, right? Then it's just 1, 1, like that, okay? So I hope this helped, get you up to speed a little bit on how you write an inequality, okay? I'm not done yet. Come with me because I want to set up the homework for you. I already did yesterday. You might recognize if you did the homework. Go to page 45. So 45, I'm going to start that one with you, 45, because we're going to add some layers to it. But I want you to try 46, 47, 46, 47, 48. Okay? It says here, writing inequalities from a word problem worksheet. So 47, 48, but also 46. Okay, so I'm going to put that on top of page 46. Homework is page 46 to 48, but I don't want you to do the whole thing. Just write inequalities, okay? The graphing and all of that, I will do with you. Not all of them, but I will come back and say, hey, you wrote them. How would you now graph this whole thing? Okay, so on top of page 46, write this down. Okay? Just write inequalities. Don't do anything else it's asking you to do. Okay? So you can define, state the implicit constraint, and then it says here, write a system of inequalities. That's as far as you will go. Okay. And so let's do 45 together before we go, and that's going to be it. Page 45. I'm not going to graph or anything like that. I just want you to write. It's very important for you to know how to do this. A bakery has 2 options for cakes. Cake A takes 150 grams of flour, B 75 grams of flour. Okay. The bakery has 50 kilograms of flour available. In order to profit, the bakery needs to produce at least 500 cakes. It seems like I just did that with you, but anyways, it's just coincidence. So A is defined variable, so we're going to do that. X, Y, number of cake A, number of cake B. And the reason why this whole page is blank is because we're going to graph it at the end. Okay. B, state the implicit constraint. There it is. And C, write the system of inequalities. And I'm going to go grab it. I'm going to highlight the restrictions. It says has 50 kilograms of flour available. That's IQ number 1. And you're like, what about the 150 and the 75? Later, right? Right now I'm just worrying about, hey, there's an inequality right there. And it says, if you keep reading, in order to profit, the bakery needs to produce at least 500 cakes. That's my other inequality. That's how I approach it. And you will notice that your homework has the restrictions in bullets. So every bullet should have an inequality attached to it. So let's talk about flour. Okay, you would say that it's 150 grams for first cake, 75 for the second cake, and it has to be less than or equal to 50 kilograms. So there's a problem there, right? I'm going to do this. 50 kilograms times 1 kilogram has 1,000 grams. So this is 50,000 grams. 50,000 grams. So that's what you put there. Okay. There's a restriction on flour. You got that. There's a restriction on the number of cakes, right? So we say that cake A and cake B, the number of each. How would you write this? I like that it changed now. It says to produce at least 500, at least. So this combination has to be greater than or equal to 500. Okay. So now you have your two inequalities, and we could now go ahead and graph them. You're gonna like these ones, guys. These are very easy to find the intercepts and graph, really easy. These ones obviously need to do a little bit more work. So I'm just gonna leave it right here. This is basically what I want you to do for those pages I assigned. Very important for you to be able to do that. And guys, if you get it wrong, you try and you get it wrong, it's not the end of the world right now. You just want to practice, okay? And kind of key in on the little things that are going to make the inequality look different. Thank you, guys.